Okay, hello, welcome to my channel. Now in this video, I want to evaluate this integral from 0 to 1, alright? Well, it's not just about the integral, but about the result we'll get from this integral. We will use the result here to determine between 22/7 and pi, which one is bigger, alright? So we know 22/7 is a rational number that we use most of the time, maybe while solving some work involving geometry. We take 22/7 to be pi, alright? But it doesn't mean that they are the same. Of course, they are not the same because pi is an irrational number while 22/7 is a rational number. And because of that, we want to determine which one is bigger, because from the law of trichotomy of real numbers, okay, if two real numbers are not the same, then one will be bigger than the other. So between pi and 22/7, which one is bigger, alright? Okay, that's great. Anyway, so let's start off with this integrand here. So you notice that this integrand is non-negative, will be non-negative for all values of x, right? Or for all real numbers. That is to say, whatever real number you plug in, we cannot have a negative result since the powers of x are all even, right? Good. So what that tells us is that this integral here will be non-negative from 0 to 1, alright? So since the integrand is non-negative, the integral will be non-negative. That is to say, the integral will either be 0, right, or it will be bigger than 0. Great. Okay, very nice. So let's evaluate this integral, and then we are going to use this fact, alright? Keep in mind. So I'm just going to clean it up. We're just going to use that fact, but let's start off by evaluating this integral. So you notice that this integrand, that is the function we want to integrate, is an improper fraction. The reason is because the degree of x in the numerator, or that is the degree of the numerator, is not less than the degree of the denominator, right? So it is an improper fraction, and because of that, we want to rewrite it as a mixed fraction. So this is how we would do. We first of all put down the x to the power 4 outside here. Then I'm going to expand this term, alright? So I'm going to expand it. This is 1 plus x to the second power. When we expand 1 minus x, we raise it to the power 4. The expansion of that will just give us, let's see, 1 minus 4x, right, plus 6x squared. That's just from binomial theorem. Let's see, we subtract 4x to the power 3, and then we are going to add x to the power 4 to that, right? Okay, that's nice. That's just by expanding this 1 minus x, and then everything raised to the power 4. So let's see. Well, see, inside this bracket, I'm going to rewrite it. I'm going to rewrite it in a way such that I can always factor out 1 plus x squared. So we will just have to divide these two polynomials, and we can do that using polynomial long division, or we will just rewrite this thing here. So let's see how we can rewrite it. So this is x to the power 4. So what can I add to x to the power 4 so that I can factor out 1 plus x squared? That's the thing, alright? So you notice that if we add x squared to this, we are going to factor out x squared. When we factor out x squared, we're going to have x squared plus 1, which is what we have in the denominator. That's how we rewrite it, alright? Or maybe just use polynomial long division from here, and then get your quotient and remainder, and you continue from there. Okay, so let's see. So after getting that out, let's see, we have, you notice that here we are having 6x squared, so we can try to balance things up by adding 5x squared. So you notice that if we add 5x squared to x, we're going to get back 6x squared. So we are just trying to balance things at the same time. And also, what can we add to this 5x squared so that when we factor that thing out, we will get x squared plus 1. Then we can add 5 to that. If we add 5 to this, you notice that factoring 5, we're going to have x squared plus 1, right? But you notice here we just have 1 as the constant term, so we need to subtract something. We need to subtract 4. 5 minus 4 will just give us 1. 5x squared plus x squared will just give us 6x squared, and this is x to the power 4. So we haven't really changed it, right? And then we have some other terms remaining, that is negative x to the power 3. Okay, let me just put those ones down. Negative x to the power 3, and then negative x, right? Negative 4x. So this is the power 3, and then negative 4x. Okay, that's nice. So we just keep the denominator the way it is, 1 plus x squared. So from what I just said, okay, you notice that, let's just split the fractions anyway. I'm going to split for each of them. So I'm going to take 1 plus x squared, take this one, 1 plus x squared, right? And let's take these two together, 1 plus x squared, and then we keep this one on its own, 1 plus x squared. So I I just split the fraction, right? So let's see what we have. This is x to the power 4. Well, when we factor out x squared from here, we'll have x squared plus 1, which will cancel out with this denominator. So here we have factored out x squared. The remaining part will be cancelled, right? Here we are going to factor out 5. We'll have x squared plus 1 left, which will cancel out with this. Then here we are going to, let's factor out negative 4x from here. We factor out negative 4x. Notice that we are going to have positive x squared here and then positive 1 here. X squared plus 1, x squared plus 1. So you will just have the factor term out, right? Then this term, we will take it last. Negative 4 divided by 1 plus x to the power of 2. Okay, that's nice. Maybe let's just split this x to the power 4 to everybody inside. That means we're going to have x raised to the power of 6, right? Let me take this one so that it will be in descending powers of x, minus x raised to the power of 5, minus 4x raised to the power of 5, plus 5x raised to the power of 4, okay, and then minus, we will multiply with this one. Let's see, that will be minus 4x raised to the power of 4. Let me write this one well so that I can have little space. Okay, so that will be minus 4x raised to the power of 4. Okay, we divide it by 1 plus x squared. Okay, that's nice, isn't it? Okay, so what we've done there is that we've rewritten the original thing, but this right here, this last term, okay, is still an improper fraction. Take note, the degree of the numerator is not less than the degree of the denominator, so we can still rewrite this last term. So I'm just going to write the last term, rewrite the last term only. So let me do that here. So notice we have 4x to the power 4. We divide it by 1 plus x squared. All right, I can rewrite this as, well, let me just put down the original thing, 4x raised to the power of 4. Then the similar thing we did here, I'm going to add things so that I can factor out 1 plus x squared. So you notice if I add 4x to the power 2 here, when I factor this thing out, 4x to the power 2, we are going to have x squared plus 1, which is what we have in the denominator, right? But I have just added something to this, so I need to subtract it, and that is what we call addition of 0. Okay, let me manage some space. Okay, so like I said, we want to subtract 4x to the power 2 because we've just changed the original thing, all right? Okay, and also well, notice that from this negative 4x to the power 2, we can write something so that we can factor out 1 plus x squared, and if we can write a minus 4. If you subtract 4 from this, all right, you notice when you factor out negative 4, you're going to have x squared plus 1. But I need to balance this by just adding the 4 back, all right? So we are going to split this. Okay, I'm going to split this fraction, and that means we're going to have 1 plus x squared, 1 plus x squared, and then 1 plus x squared. This has been rewritten as that, all right? So maybe let's factor this a little bit and see. When we factor out 4x squared, what we will be having left will be x squared plus 1, which will cancel out with the denominator. We factor out negative 4 from here, we'll have x squared plus 1, which will cancel out the denominator, and then we have plus 4 divided by 1 plus x squared. So all of this, okay, we'll replace this one here, all right? So maybe I can clean some things a little bit, and we are going to see that the whole of this will become, well, notice this was a negative here, negative of this term, that will be negative 4, let me just put this down, negative 4x squared. Then negative of that will become positive 4. The negative of that will become negative 4 divided by 1 plus x squared. So all in all, the integrand, okay, has been rewritten. The integrand, which is what we have inside here, we've rewritten it as this, okay? So what we'll be doing now will be to integrate all of these from 0 to 1. So in fact, I'll clean everything, I'll put this one here, and then we will start and we'll continue solving. Okay, so after rewriting the integrand, we just integrate this because it's really easy from here, all right? So you notice this is going to become, well, when we integrate all of this, we are going to have 1 over 7. Okay, we put x raised to the power of 7 here. That is just the integral of x to the power 6. Using the inverse power rule, this is going to be negative x to the power 6. Okay, now 4 divided by 6, x raised to the power of 6. And then we're going to add it with, well, this is going to be x raised to the power of 5, right? We'll divide it by 5, but this coefficient will cancel out with that denominator. And then this is going to be negative 4 divided by 3. And then, okay, let's just put the x. When we want to evaluate, we are going to look at that. This is negative 4. This is power 3. This is negative 4x. And then negative 4 times, well, the integral of this one, right, will be inverse tangent of x. When you take the integral of 1 over 1 plus x squared, we get inverse tangent of x. And don't forget, we have to take this from 0 to 1. All right. Okay, that's great. So let's see. Notice that all of these from here to here, they all have x. All right. So when we substitute 0, which is the lower bound, everything will be 0. And inverse tangent of 0 is also 0. So everything will be 0 when we substitute 0. So we'll just substitute 1 and we continue, right? So substituting 1 here will be 1 over 7. And then we subtract, well, this is 2/3, right? And then, well, we add it with 1. Okay, this is 1. And then we subtract 4/3. And then we add it with 4. Well, notice that inverse tangent of 1 will be pi over 4. You know, tangent of an angle gives us 1. Then the inverse tangent of 1 will be that angle, and that angle has to be pi over 4. Okay, just the principal value anyway. So this is 4, and then we take this to be pi over 4, right? Okay, great. Remember, when we substitute 0, everything will be cancelled. Now you notice that all of this, okay, negative 2/3 plus negative 2/3 minus 4/3 will give us negative 2. Negative 2 plus 5 will give us positive 3. So we have 1 over 7 plus 3, right? Then plus, well, let's see. Okay, this is minus. Sorry about that. This is minus. Okay, let's see. That will be pi, right? 4 will cancel out with 4. So 1 over 7 plus 3 will just give us 21 plus 1, that is 22 divided by 7. This is minus. I had to still put plus. 22 divided by 7. So this is going to be 22 over 7 minus pi. Alright, so this is the result we get after evaluating this integral. So what that tells us is that this integral is equal to 22 over 7 minus pi. Isn't that nice? But remember what we said earlier, that this integral, okay, will be non-negative since the integral is non-negative. That is greater than or equal to 0 for both cases. That tells us that this right here is greater than or equal to 0 because it is just the same thing as the integral, right? But we already discussed earlier that 22 over 7 and pi are not the same. Therefore, the difference cannot be 0. So in fact, their difference is strictly greater than 0. And since the difference is strictly greater than 0, this tells us that 22 over 7 is strictly greater than pi. Okay? Because you subtract a smaller thing from a bigger thing for us to have a positive result. So what that tells us is that pi is smaller than 22 over 7. And in fact, they are not the same. So 22 over 7 is bigger than pi. And this is it, right? We just use this tool to compare the two. And I don't know if it will really be difficult to, do the comparison using some other methods. I don't know. Maybe if you have some other way, all right, of comparing between 22 over 7 and pi, which one is bigger, please put your solution in the comment section, okay? And I'll pin it anyway. All right, thanks for watching, and please, if you enjoyed this video, please subscribe to my channel, share it with your friends, and I'll see you in our next video.